Physics Part 58. Question 3a. Calculate the angle of the projection of the ball and the distance of the point where the ball was kicked from the goal line. 3b. Also calculate the horizontal velocity of the ball as it passes over the crossbar. Question 3c. For how long is the ball in the air before it reaches the ground on the far side of the crossbar? Question number 4. An athlete competing in the long jump leaves the ground at an angle of 28 degrees and makes a jump of 7.40 meter. A. Calculate the speed at which the athlete took off, and if the athlete had been able to increase their speed by 5%, what percentage differences would this have made to the length of the jump? Number 5. A hunter armed with a bow and an arrow takes direct aim at a monkey hanging from the branch of a tree. At the instant the hunter releases the arrow, the monkey takes an avoiding action by releasing its hold on the branch. By setting up the relevant equations for the motions of the monkey and the motion of the arrow, show that the monkey was mistaken in its strategy. As it was mistaken in the strategy, there can be a negative result on it, and we can find the real ending to it. The monkey was mistaken in its strategy. Now we get to our chapter number 4, Work, Energy and Power. Chapter number 4, Work, Energy and Power. Machines are such as wind turbines do work for us. They change energy from one form into some other, more useful form. This chapter deals with the subject of energy in its various forms. Not only is the availability of useful forms of energy important, but also the rate at which it can be converted, but also the rate at which it can be converted from one form to another. The rate of converting energy or using energy is known as power. Work. At the end of our section, you should be able to show an understanding of the concept of the work in terms of the product of a force and displacement in the direction of the force. Next, at the end of the section, you should be able to calculate the work done in a number of situations, including the work done by a gas which is expanding against a constant external pressure. W is equal to P delta V. The word work is in use in everyday English language, but it has a variety of meanings. In physics, the word work has a definite meaning. The vagueness of the term work in everyday speech causes problems for some students when they come to give a precise scientific definition of work. Work is done when a force moves the point at which it acts, the point of application, in the direction of the force. Work done is equal to force into distance moved by the force in the direction of the force. The weightlifter uses a lot of energy to lift the weights, but they can be rolled along the ground with little effort. I am going to work today. Where do you work? I have done some work in the garden. Lots of work was done lifting the box. I have done my homework. See, these are the different instances in language and literature But when we talk about physics, physics has got a very different definition to work.